Who was Srinivasa Ramanujan, the genius who leaves mathematicians speechless? Born in 1887, Ramanujan grew up in Madras state, now called Tamil Nadu, in southern India. He fell in love with mathematics early. By age 11, he had exhausted the mathematical knowledge of two college students who were lodgers at his home. When he was 16, he obtained the book A Synopsis of Elementary Results in Pure Mathematics by G.S. Carr. Though this book was essentially a study guide, Ramanujan intensely studied this book with its 5,000 theorems, and it is credited with awakening his genius. Ramanujan spent hours producing his own new formulas on a slate with only the best findings transferred to a notebook. He was too poor to afford much paper. A simple example states that if a plus b plus c equals 0, then this formula relating fourth powers is also true. Another early head-turner is this equation involving infinitely many nested square roots. Although Ramanujan had won a college scholarship, he had no taste for non-mathematical subjects, namely English, Greek and Roman history, and physiology, and so he flunked out of college twice. While supporting himself as a clerk, Ramanujan's mathematical mentors encouraged him to show his work to mathematicians in England. The first two professors to whom he wrote, H.F. Baker and E.W. Hobson, simply returned Ramanujan's papers without comment, but the third one, the renowned Cambridge professor G.H. Hardy, had a positive response. Ramanujan's 9-page letter included mesmerizing formulas such as this infinite series involving the reciprocal of pi, or this infinite continued fraction involving both pi and e. When Hardy and his close collaborator J.E. Littlewood read over the sampling of Ramanujan's results, they were overwhelmed and became convinced that Ramanujan was a genius. Hardy would later write, "These equations had to be true because if they weren't, nobody could have imagined them." Hardy invited Ramanujan to do research with him at Cambridge, and so in 1914, Ramanujan sailed for England. His formulas had a bewitching effect on many researchers. The Hungarian mathematician George Polya borrowed one of the notebooks from Hardy, but returned it quickly because he was afraid of getting sucked into Ramanujan's world and stopping his own research. One research area that Hardy and Ramanujan worked on was the theory of partitions. Let's start with an easy question. How many ways can the number 7 be written as a sum of natural numbers? It's easy to list the possibilities, ordering the parts from largest to smallest, and find 15 ways. But how many partitions are there of the number 50? The number of possibilities explodes, but a careful analysis shows that there are exactly 204,226 ways. In their study of partitions, Hardy and Ramanujan had several breakthroughs. Today, partitions are connected to many areas, from as simple as the number of ways to make change for $1 using these different coins, can you count them all, to Bose-Einstein condensation in statistical mechanics. Also connected to partitions, Ramanujan discovered what are now called the Rogers-Ramanujan identities. Some fascinating properties of partitions follow from these mysterious formulas. Here's an example. Let's restrict the partitions of 11 in two different ways. Those where all the parts differ by at least 2, and those where each of the parts end with either 1, 4, 6, or 9. There are 7 partitions in each of these restricted classes. The Rogers-Ramanujan identities imply that these totals match for the partitions of any number n. Ramanujan found life challenging in England with his long-standing health problems, isolation, and the scarcity of vegetarian food. In 1917, he was confined to a sanatorium. An interesting story occurred during this period. Hardy visited Ramanujan in the hospital and said that he had ridden in taxicab number 1729 and remarked that the number seemed to be rather dull. "No," replied Ramanujan. "It is a very interesting number. It is the smallest number expressible as the sum of 2 cubes in 2 different ways. Indeed, 1729 can be written as 1 cubed plus 12 cubed, or 9 cubed plus 10 cubed. In fact, Ramanujan found infinitely many equations where the sum of 2 cubes is just 1 away from another cube." Ramanujan was the master of numbers. Upon hearing the taxicab story, Littlewood commented that every positive integer is one of Ramanujan's personal friends. When he was eventually well enough to leave, he returned to India, supposing that the warmer climate and reconnection with his family would bring him back to full health. Upon his return, Ramanujan was offered a professorship at the University of Madras and was welcomed as a hero. His strength, however, ebbed away, and he died at the young age of 32. Ramanujan's romantic story did not end with his death. Decades later, Bruce Baird published many books about Ramanujan's findings. In 1976, George Andrews visited Cambridge and found some notes that Ramanujan had written hidden away in Wren Library. These notes are now referred to as the Lost Notebook and have also been studied closely. Despite growing up in poverty and being self-taught, Ramanujan pitted his brains against the accumulated wisdom of Europe and produced mysterious and powerful formulas that still leave mathematicians awestruck. It is no wonder that Ramanujan has been called the man who knew infinity.